A student requests that we do practice problem 21.4.5 from the textbook in a video. Section 21.4 in the book is about the Claisen rearrangement, where we take an aerial allyl ether and heat it up. It undergoes a sigmatropic rearrangement, meaning it goes around in a circle, and the pi here becomes a sigma here. There's the red sigma. The old pi breaks and becomes a new pi here. And the sigma between the C and the O resonates in to become a ketone. We don't have to worry about intermediates in a synthesis question, and that's what 21.4.5 is. The end result after tautomerization is a phenol with a new group on the ortho position. I wrote it backwards because that's how we have to think of this problem here. It's a retrosynthesis problem. There's our target. Let's make ours line up with this target. Rotate it 60. All the parts match up. The OH is where it needs to be. So we got that going for us. And that is this molecule here. That's our target. The new bond was between 1 and the aromatic. What was it before it was that? Well, there was no bond between the aromatic and carbon 1. There was a bond from the O to carbon 3, which in our example has 2 methyls on it. O is bonded to carbon 3 with 2 methyls on it. That's 3. 2 doesn't have anything special. 2 goes to 1, which has a methyl on it. And the double bond had to be between 1 and 2. Let's put our numbers on before we forget where we were. 1, 2, 3. Double bond used to be between 2 and 3, and now it's between 1 and 2. And there you have that molecule. Now the question is, how do you make an aerial allyl ether? Usually we think about an SN2 reaction. Although this might be a difficult scenario on this one. This would be our nucleophile. And our electrophile would look like this. Can't have an O, but it would have a leaving group on it, like a BR. And that's a tertiary carbon with a leaving group. I'm not thinking that an SN2 reaction is going to work here. Normally I would be thinking SN2 between a nucleophile and a carbon with a leaving group, but a tertiary carbon, forget it. I could probably make an SN1 work though, because tertiary allylic makes cations basically in its sleep. So there we go. We got a nucleophile and an electrophile. Those two together. Where's my plus sign? Right up here. Would react to make the aerial ether we need, which will undergo a Claisen condensation. We'll show the forward synthesis eventually. With the wording of the question, as long as you have a hydroxy aromatic compound, you don't have to go back further from that. That is a hydroxy aromatic compound. Most of our retros don't let us start with alkyl halides, typically alcohols, but you know, doesn't say anything about that up here. So I think we're good to go. Let's do the forward synthesis. This combined with this in an SN1 reaction would give this combination here. This is the answer to question A. And under heat, this would create our target, which is this. We did redraw it here. It'll look more straightforward that way. And that is the answer to your question right there. I'll highlight it. Similarly, I did a copy of the target B. I've got a weird message here, I'm sorry.